Okay, problem number 11. Same thing we've been doing. Let's make this log base 3 of the square root of 3 equals 4x plus 5. We change that from exponential into log form. And then we can just subtract 5. So this is something we can easily do on our calculator and divide everything through by 4, and that will give us x. In the calculator, that gives me negative 1.125, or if you prefer a fraction, negative 9/8. Okay, problem 12. We've got this natural log expression. Let's simplify this by making it a natural log of x to the 6th divided by x to the 5th, because we have a property that says that the log of a quotient is equal to the difference of two logs. So we're going backwards. X still equals 1. 5 of these cancel with 5 of these, leaving 1 left, so we have the natural log of x equals 1. That's rewritten as an exponential equation, e to the first equals x, so our answer is just e to the first. Okay, the next problem gives us this. I'd probably divide both sides by 9, in which case I get e to the 2t equals 8 over 9, e to the 0.81t. And then I'll take the natural log of both sides, and that gives me 2t equals natural log of 8 over 9 e to the 0.81t. I could simplify this even a little bit more. I don't know if Webwork needs me to or not, but I can break this up into the sum of two logs, because we know that property that says that if we have a log of a product, we can make it the sum of two logs. I don't know if that's going to help at all, but if we do, this gives us 0.81t. I can subtract that to get 1.19t equals natural log of 8 over 9. And then I can divide that by 1.19 to get t by itself. That's an exact value. I'm not sure if that's what they're looking for. Webwork's down right now, so I can't check that, but this should work as an exact value. If not, we'll have to try something else in class. And an easier way to do this probably is to divide both sides by 9, and then divide both sides by e to the 0.1t, so you get this equation. And then when you have like bases, you can subtract the exponents, and then you can change this into log form. Natural log base e of 8 over 9 equals the exponent, or take the natural log of both sides and then divide both sides by 1.19. So that's probably even an easier way to do it. But that's what I'm getting, so hopefully that works and works out. Okay, the next problem, once we have the difference of two logs, so right away we know that's a log of a quotient if they have the same base, which they do. So I can rewrite that like this, and then I can change it into exponential form like this. And unfortunately I can't simplify this at all, so I'm going to have to multiply. This is 100. I'm going to have to multiply both sides by 3 plus x. And I'm probably going to have to distribute that 100 to both terms, so I get 300 plus 100x equals 1 minus x. And I'm going to have to add x to both sides, so that'd be 101x. And I'll subtract 300, so it'll be negative 299. Divide both sides by 101. And I should get x equals this number. And I can enter that as a decimal or a fraction probably. And it does say exact answer, not decimal, up above, so make sure you enter this in. Okay, the next problem gives us natural log of x. So I'm going to write that in exponential form. That's natural log base e, so e to the 1 equals natural log of x. Base to the exponent equals the argument. Now I'm going to do it again, so this is really base e, so I'll do base to the exponent, so e to the 1 equals x. So e to the e, you can do it in your calculator, and you're going to get about 15.15 if you do that. And then next problem is this one here. I'm going to try dividing both sides by e, so I have e to the 8x divided by e to the negative x. So all I did was divide both sides by e to the negative x. When you have like bases, you can subtract the exponent, so I have 8x minus negative x, which is really 9x. So this is really e to the 9x equals 8. And then I can change this into log form, so natural log base e of 8 equals 9x. Divide both sides by 9, and there's my answer right here, which I can probably do as a decimal, 0.231. Okay, the next problem says the city had a population of 7,935 at the beginning of 58 and been growing at 7.2% per year since then. Find the size of the city in 1986. Okay, we're looking at exponential equations, and the next few problems are going to be application with or modeling with exponential equations. So the starting amount is 7,935. The growth rate is going to be 1 plus the rate that it's growing per year, which is 0.072. So this is going to be 1.072 raised to the t power, where t is in years. Now, 1986 is 28 years afterwards, so if we plug in 28, we can get the population 28 years afterwards, which gives us 55,590.54 would be the population. Now the next question for part B, when will the population reach 4.8 million? Well, I can use my same equation, only just set it equal to 4.8 million. And just divide both sides by 7,900, then take the natural log of both sides, or change it into log form, either way, and solve for t. And if you guys do that, you get about 92.13 years afterwards, or I guess we'd write that as 2,150 is when the population would reach 4.8 million. Actually, this is 2050, sorry. 92 plus 1958. Okay, the next problem, I know we've done problems like this, but it says the population doubles every 32 years. So that's y equals ab to the x for our exponential growth. And it doubles, so that's going to be our growth rate, but we need to do an exponent of, instead of x, I'll use t, and I'll do divided by 32, so that when we stick in 32, the population would double and we'd go from a to 2a, basically. But I'll just keep this y, and it doesn't matter what we start with. What we're looking at is they want the annual growth rate. So let's rearrange this as 2 to the 1 over 32 to the t power, and we can compare this now. If we do this in our calculator, we get 1.02189, and so that means 1's our initial amount, so afterwards, you know, it'll be 0.02189 that we're adding to it, which is really 2.189%. You know, or I don't know, 2.18 might work. So I would use 2.19 for this, and that worked. Now the next question is the continuous growth rate. So for continuous growth rate, I'm going to go back up and compare this same thing now to y equals a e to the rt, which is our continuous growth rate form on the formula sheet. So obviously this has to be equivalent. 2 to the 1 over 32 has to equal e to the r. So I'm going to change that into log form by doing natural log base e of 2 to the 1 over 32 equals r. And if you do that in your calculator, you should get 0.02166. And if you change that to a percentage, 2.166% will work. All right, next one, it says town's population, 225 people at t equals 0. They just gave us an order pair, t 0 equals 225. And they give us the y-intercept of the graph. So that's important. So then if they want us to write an equation for population P in terms of year T, where it grows by 75 people per year, that's linear. If it grows by 75 people per year, it's a linear equation where we have the y-intercept, so that's y equals mx plus b, where the slope is 75. We're gaining 75, so it'll be 75t instead of, use t instead of x. And the y-intercept is 225. So that would go here, 75t plus 225. Next one grows by 12% per year. That's exponential growth. A growth rate, it starts with 225, and it grows by 12%, so it'll be 1.12. We add, 12% or 0.12 to 1. So that'd be this equation here. Okay, the next one is continuous growth rate of 12%. That formula's on our formula sheet. I don't know exactly how it's written. I think it's P and A here. But this A is the starting amount of 225. The interest or the growth rate is 0.12 times t, so we enter that in right here. And if it shrinks by 18 people per year, that's going down by 18 people per year. That's linear again, where the slope is negative 18, so it'll be negative 18x plus 225, so that's linear, or negative 18t. And if it shrinks by 6% of people, that's 1 minus 0.06 for the growth rate in y equals ab to the x, because that's exponential. So the starting amount for A is 225. 1 minus 0.06 is 0.94. to the T. So that would go in right here. So if we're shrinking by 6% of people each year, we're really maintaining 94% of the population every year. And the last one then, y equals a e to the RT. You start off with 225, and the continuous rate is shrink, so that'd be negative 0.06 t. That will go right here. Quick, if you guys don't mind. All right, next question. Okay, the next question says half-life of palladium 100 is 4 days. After 12 days, the sample has been reduced to a mass of 6 milligrams. So they give us an order of pair 12, 6. Right after 12 days, we get 6 milligrams left. We know we're talking about exponential decay here. We don't know what we start with. We know it has half the amount remaining after 4 days. So if I use this equation, that works because if I plug in 4, this gives an exponent of 1, and so we're multiplying by 1/2, so we'll have half the amount that we start with, which is what we want. So use this order of pair now, plug in 12 for t, and plug in 6 for y, and we'll find a. So we get 6 equals a 1/2 to the 3rd power. If we divide both sides by 1/2 to the 3rd power, then we get a 48. So my equation becomes then, if I plug in 48 here, there's my equation. So the first answer is 48, and I can use this equation to answer the second question, which is what's the mass 8 weeks after? 8 weeks would be 8 times 7 days a week, which is 56 days. So we're plugging in 56 days right in for that t, because this t has to be in days. And if we solve that, that gives us a small decimal like 0.0029297-ish for how much amount, and that's in micrograms or milligrams goes here. All right, last problem then. If you have 100 micrograms of a certain radioactive material, that's exponential decay. So we start off with 1,000 micrograms. We know it decays at 7%, so the 1 minus 0.07, which is 93%, and 0.93, raised to the t power, where t is in years. So if we plug in after 1 year, we get the first answer, which is 930. After the 2 years, we plug in 2 right here, and that gives us 864.9. And then after 10 years, we plug in 10 right here, and that gives 483.98 micrograms.